Gauss law is a fundamental law of physics. Now, Gauss's law, a statement. Gauss law, the total electric flux due to net electric field through a closed surface is equal to 1 by epsilon naught times the total charge enclosed inside the surface. Here, Gauss law is applicable for closed surface, and it gives the relation between the total electric flux and the charge configuration. Mathematically, it can be expressed as total electric flux is given by integral E dot ds. Total electric flux through a closed surface. If the surface is closed, then we put a small circle here. This is for closed surface. Total electric flux through closed surface is equal to 1 by epsilon naught times the total charge enclosed inside the surface into charge. Please note that the electric field in the left hand side is the net electric field, that is due to all the charges which is outside or inside the surface. But the charge in the right hand side is only the internal charge, that is the charge enclosed inside the surface. So we can write here IN for internal. This charge is internal charge. So mathematically, Gauss law can be expressed like this. Simply, Gauss law gives the relation between electric flux and the charge configuration. We can find the electric flux if we know the charge inside a closed surface, and it also gives the electric field in terms of charge configuration. So we can apply Gauss law to find the electric flux if we know the charge inside the surface, and it is also used to find the electric field intensity due to charge configuration. Proof of Gauss law. Suppose a charge Q is placed at the center of a sphere of radius r. This is the center of a sphere of radius r, and a charge Q is placed at its center. Suppose we have to find electric flux through the sphere. Since the sphere is a closed surface, so electric flux through the sphere is given by integral E dot ds, and it is a closed surface. For this, consider a very small area element ds vector. Its direction is outward normal along this direction, and you know that electric field due to a point charge is radially outward if the charge is positive. So the direction of electric field is also outward direction. Here the angle between electric field and ds vector is 0. So we can write integral E ds cos 0 degree, and cos 0 is equal to 1, so it is equal to integral E ds. Now electric field at every point on the surface of a sphere is equal in its magnitude, as all the points on the surface of a sphere are equidistant from its center. So electric field is constant. We can write electric field E integral ds. Integral ds is always equal to the surface area, and here the surface area of the sphere is 4 pi r square. So it is equal to E into 4 pi r square. You know that electric field due to a point charge r distance away is equal to 1 by 4 pi epsilon naught q by r square and 4 pi r square. 4 pi r square cancel and we get q by epsilon naught. That is, total electric flux through a closed surface is equal to q by epsilon naught. Integral E dot ds is equal to q by epsilon naught. This is Gauss law. We can verify Gauss law for any type of closed surface. Gauss's law. The total electric flux due to net electric field through a closed surface is equal to 1 by epsilon naught times the total charge enclosed inside the surface. Gauss's law is applicable for closed surface. The total electric flux through a closed surface is denoted by integral E dot ds, which is equal to q by epsilon naught. The electric field in left hand side is the net electric field, but the q in the right hand side is the charge enclosed inside the surface. Proof of Gauss's law. Consider a charge q is placed at the center of a sphere of radius r. Consider an area element ds whose direction is outward normal. The direction of electric field due to charge is also radially outward. We have to find the total electric flux through the sphere, which is given by integral E dot ds, which is equal to integral E ds cos theta. Since the angle between electric field and area vector is 0 degree, so it becomes integral E ds cos 0. The value of cos 0 is equal to 1, so it becomes integral E ds. E is constant at every point on the surface of a sphere. So it becomes E integral ds. The value of electric field r distance from a charge is given by q by 4 pi epsilon naught r square, and integral ds is equal to the surface area of the sphere, which is 4 pi r square, and we get q by epsilon naught. Hence proved.